So this is 1.6a, the first video on lesson 1.6 in college algebra, starting on page 134. The name of this section is the algebra of functions. So we're going to start out with the algebra of functions, sums, differences, products, and quotients in the middle of page 134. One of the things you want to do is make sure you have that purple box 3/4 of the way down the page with those bits of information in it. And this is stuff that we have done before, where we take two functions and add them together. And basically that means we take the function of the first one and we add the function of the second one, and we get our answer. So for example, if f of x equals x plus 1 and g of x equals the square root of x plus 3, then if I throw out finding, let's see if we can get that to work. Plus g of x, that's going to be again f of x plus g of x. So if we put numbers in there for f of x, because we did say that f of x actually is x plus 1 and g of x is actually the square root of x plus 3. So in red, what I'm going to do is I'm going to put x plus 1 here instead of that, and I'm going to put the square root of x plus 3 here instead of that. And since that cannot be simplified, that's as far as we go for that. Now if I made that plus sign here negative, then this would be negative, and if I made that a multiplication sign, it would be this times this. Okay, so, or even if I did a division, if I had x or f over g of x, that would be x plus 1 over the square root of x plus 3. Okay, so way to write it there. And then in example 1, part B, what they do there is they are asking, we'll take that same bit of information that, let's see, that they gave us, and so what I'm going to do here is I'm going to take f plus g of 6, and that will equal f of 6 plus g of 6, and then using this formula right there, instead of writing f of x equals x plus 6, I'm going to write f of 6 equals 6 plus 1, because what I'm doing is whenever I have a 6, I'm going to replace it here. And then I'm going to continue with my plus sign, and then I'm going to take g of 6. Well, g of 6, g of x equals x plus 3, so g of 6 is going to equal the square root of 6 plus 3. So there I get 7. There I get the square root of 9, so therefore I get 7 plus 3 equals 10. So, real quickly, just to give you a reason why this worked, is because we said that g is in the domain of f, or 6 is in the domain of f, and 6 is in the domain of g. Now, since that is true, then the answer, 10, is a real number. So in this particular one, and these domain and range things get to be a little bit confusing. I don't want to go into a lot of detail, but the domain of G is all real numbers. The domain of F is all real numbers. So because that's true, this gives us 10. Now notice, in our x plus 3, there are some numbers that do not work. If we put any number less than negative 3 in here, it will give us a negative radical. And that means that it would not be a function. And it needs to be a function. So the only number, or any number in the whole wide world, all real numbers work for this. But numbers over here, they have to be somewhere between negative 3 and positive infinity. We cannot put, if we put a negative 3 in here, that gives us a 0. Square root of 0 is assumed to just be 0. So that works. But negative 4 would give me a negative 1 here. And that is not going to work because it would not be a function. Okay, so it's not graphable. So g of x, the domain has to be negative 3 to positive infinity. The domain for f of x can be anything, because anything plus 1 still gives you a real number. So what we're looking at is, when we put an x in here, are we getting a real number? When we put an x in here, are we getting a real number? If not, what numbers make this a non-real number? And in this case, it's any number less than negative 3. So we're not going to include that in our domain. We're only going to include these numbers that will work with this problem. Okay, they didn't ask you for any of that in this problem, but it is good to remember that this stuff is necessary to know. So let's look at f plus g to the negative 4th power. So what we're going to do is we're going to take that negative 4 and put it in here and put it in here. Okay? So what we've got here is we need to first of all determine whether negative 4 is in the domain of each function. So again, how we do that, let's put negative 4 in here. When I put a negative 4 in there, what do I get? I get a negative 3. When I put a negative 4 in here, I get a negative 1. That means that negative 4 is not in the domain of g. It doesn't work. Okay, the only numbers that work are, like I had earlier up here, negative 3 to positive infinity. So because negative 4 doesn't fit into that interval, it's not in the domain of g. So f of g of negative 4 does not exist. You cannot solve that, because if I tried, I would get negative 4 plus 1 plus negative 4 plus 3, so I'd get negative 3 plus the square root of negative 1. That does not give me a real number. So therefore, f plus 4 to the negative 4 does not exist, because when I put the negative 4 in, I get a number that is not a real number. So that's not gonna fly. So you just don't get an answer. You just say it does not exist. Okay, so this is example 2 on page 136, and you shouldn't have any trouble with this. All we're going to do is take our f of x and add our g of x. And then that gives us x squared plus x minus 2. Okay? So then we go to, let me make that 2 a little better. Okay, so let's look at the next one. So again, we have x squared minus 4, and what they're doing in this one is they're multiplying it by g. And when you multiply those two together, you end up with x cubed plus 2x squared minus 4x minus 8. So that's as simple as you can go. Now when you look at the next one, the division one, it's going to be the function of x over the function of g. Well, let me do that correctly. It's going to be g of x. Okay, so that's what that equals. So f of x equals x squared minus 4, and g of x equals x plus 2. And my x squared minus 4 is the difference of two squares. And I get that, and I get an x plus 2, and those cancel, and I'm left with x minus 2. So f over g of x equals x minus 2 with the added stipulation. Notice up here before we canceled, and this is important to remember, before you cancel, x cannot be negative 2 because that will make it undefined. So you need to remember that the only numbers that will work for f over g of x are going to be in the interval of negative infinity to negative 2, not including, and negative 2, again not including, to positive infinity. So this is the set of numbers that will work for f over g of x. So basically all real numbers except negative 2. So that takes us to page 137. Next video we'll start talking about difference quotients.